Okay, so 8.1 is just a review of integration. We took all those e to the x, a to the x, natural log, log base a. We were thrown a lot of different functions. A lot of different functions were thrown at us in chapter 5 before we learned how to solve differential equations and find volumes of solids. So before we get into getting into really that Calc 2 or Calc BC material, we need to review all of that integration that we've done and like see a bunch of problems together at the same time. And remember that quite often you can't just follow an integration rule without doing some preliminary work ahead of time. So here's all of our integration rules that we've learned. The number one thing that I can tell you moving forward, and you've already experienced this as we went through near the end of chapter 5, is you need to look at your integration rules and identify which one of them are closest to the problem that you're currently doing to give you some guidance on what the heck to do to integrate that problem. We have here, for example, number 1, an indefinite integral of 3 times x plus 3 squared over x cubed plus 9x squared plus 27x dx. What rule does it seem like we're going to use to do this integral? Arctan? Arctan's a possibility. There was some problems at the end of chapter 5 where we had to do some completing the square to get a sum of squares, but we're not going to have to go that far. Why do you say natural log?
Because like the power in the denominator is like 3, and the degree in the numerator is 2.
Yeah. So your main characteristic of this integrand is that you have a division in it, right? So you only have 4 integration rules that have division. Now, the derivative of natural log makes a 1 over x. The derivative of a square root function makes fractions. There's there's a couple of other functions that we can take derivatives of, and we're trying to undo that derivative process with integration that creates division. So sometimes we can get into a whole nother rule that we weren't expecting, but we have 4 integration rules that involve division, and you should always go to the most, what should be the easiest first. We do a lot more of integration involving natural log than we do inverse trig functions. So we've got that 3rd degree in the denominator. We ultimately are going to have a 2nd degree in the numerator. Yeah, the derivative of a 3rd degree is 2nd. This is probably just going to end up being some kind of natural log function. So we're going to expand the numerator. I'm also going to take this 3 and move it out front. That's usually going to make your life easier. Anytime you have a constant coefficient, move it out front. We have x squared plus 6x plus 9 over x cubed plus 9x squared plus 27x dx. And, we're starting Calc 2. We're in Calc BC. We've done a lot of practice with integration. You probably don't need full-blown u-subs anymore. So we're going to just mentally or maybe write some stuff on the side to set up a u-sub, but not actually need to complete it. In terms like just complete the chain rule as opposed to actually doing a u substitution. Let u be x cubed plus 9x squared plus 27x. And then du is going to be 3x squared plus 18x plus 27 dx. Okay. Well, here I thought that I was doing myself a favor by factoring the 3 out. So we have just an x squared plus 6x plus 9 in the numerator. But if we see over here, we have a 3 and an 18 and 27. If we divide all these by 3, we're going to have that perfect match for dx. So 1/3 du is x squared plus 6x plus 9 dx. And there is our x squared plus 6x plus 9 dx. We are literally looking at an integral in the form of u prime over u. So the integral of u prime over u is natural log of u, absolute value of u. So we have 3 times the natural log of the absolute value of x cubed plus 9x squared plus 27x squared plus c.
Isn't there no 3? Because
What'd I forget?
I need divide by 3.
Yes, I do. Yes, I do. Yes, I do. Yes, I do. Okay, so I should have actually completed the u substitution. Or, scratch that. What's that? Cut. That's okay. I make mistakes. I'll just leave it in there and make a correction. So, yeah, I kind of buggered myself up there. So let's take the 3 and actually multiply it back in. And have our definite integral of 3x squared plus 18x plus 27, I teach this for a living, over x cubed plus 9x squared plus 27x dx. That, thank you, is our u prime over u. And we have the natural log of the absolute value of x cubed plus 9x squared plus 27x plus c. All right, that deserves a point. I need all the help I can get. Awesome. We go with that? All right, so as we go through these, everyone's going to be a little bit more complicated. Yeah, we'll leave it up there. So for our next example, how much time we have left? 35 minutes. Yeah, this is a good one. How about integrating indefinite integral of x times 1 minus 1 over x to the third power? It's a long silence. I'm glad I did this. Y'all are staring at that list of rules for quite a while. Why are you looking so long? A little stuck. All right. It's only to the third power. Well, look, first of all, unless you're doing integration by parts, there's no product rule for integration, which is a lie. We have integration by parts. We're in Calc 2 now. But that hopefully is not what we have to deal with. So in integration, do we have a square root in the denominator? Definitely not. Do we have a sum of squares in the denominator? No. Does it involve trig? No. Do we have a fixed base? Do we have a fixed base and variable exponent? No. How about a e to the x? No. So basically, this example is going to have to be integrated by either using power rule or something involving natural log. And this integrand, this kind of ugly looking integrand, looks nothing like u to the n or u prime over u. So your first instinct is right. We have to clean up this integrand. We have to kind of basically expand stuff out. And it's not like it's a fifth power. If it was like a fifth power or something, I might be talking about, like, you know, reminding you of expansion of binomials using that binomial theorem, where it's only the third power, though. So it's not going to be that big of a deal. What do we have to do first inside here? I don't really want to do x to the negative 1 to the third. How about we just add these two terms together and get the definite integral of x times x minus 1 over x to the third power. Now, obviously, that denominator is just going to be x to the third. In the numerator, we just have to do x minus 1 to the power of 3, which I guess let's just talk about that. Remember Pascal's triangle? 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. These are your coefficients for raising a plus b to the power of 3. So we've got 1, 3, 3, and 1. Now if I say something silly, y'all are going to have to give me some help. We're going to have times x to the third, x to the second, x to the first, and then x to the 0 power. And then our second term, the binomial expansion formula it's for the addition of terms, not the subtraction of terms. So we have a -1 to the 0, a -1 to the first, then to the second, and then to the third. We're adding these together. So we have x cubed, -1 to the first is -1, so minus 3x squared. -1 squared is positive, so we have a plus 3x. And then -1 cubed is -1. Let me double check that. Yeah. So we have an indefinite integral of x over x cubed times x cubed minus 3x squared plus 3x minus 1 dx. But of course, this factor of x is going to cancel with one of the three factors of x in the denominator. You probably will not have, in college you'll have questions this ugly, but this one's a little bit nasty for, potentially difficult for just AP, but nothing wrong with over prepping a little bit. Okay, so here now we're to this point. What's the last thing we need to do before we integrate? I really wish the solutions guide to this book did not keep doing that, because I keep hearing that. You can, but I really wish you guys would do what I've been begging you to do all year, is you have an algebraic numerator, like there's no trigger, nothing like that, and a simple x squared in the denominator. What's going to ultimately happen once you distribute that x to the -2 is you're going to get a bunch of separate terms. I think it's really going to be easier if you just mentally break this up into 4 terms and do the division, as opposed to bringing the x up and having it x to the -2 and then distribute. It's going to get to the same thing. But, and your work is usually like super on point. But x cubed divided by x, it is always on point, is x. X squared divided by x is just going to be 1. So we have a -3. And then we have plus 3 over x. Or you can write that as 3 times 1 over x, which probably is going to be better for the purpose of this question.
Can we do x to the -1?
X to the -1, I would not. You'll see why in a second.
Oh, okay.
And then -1 over x squared is going to be minus x to the -2 power. Why is it, it's nothing wrong with it, but why would it not be beneficial to write this as 3 times x to the -1?
You can't do power.
Yeah, it'd be kind of funny, right? Because the integral of 1 over x is natural log of x. So this is now finally done in terms of the simplification process. We can then just integrate each part. What's the integral of x? 1/2 x squared over 2. You guys keep talking really quietly. What's the integral of -3?
3x.
-3x. What's the integral of 1 over x dx? Natural log of x. So it's 3 plus 3 times the natural log of the absolute value of x. Don't forget that. And then we have a variable base fixed power. Power rule. Raise the power up by 1. -1 and divide. So minus, I'm going to write that just for teaching, times raise the power up, divide by -1, plus c, so 1/2 x squared minus 3x plus 3 natural log of the absolute value of x plus x to the -1 plus c. Okay, keeping with the algebra theme, we have the indefinite integral of x squared minus 3x plus 2 over x plus 1 dx. I've said many times I had to retake Calc 1 in college. And now I'm teaching like engineering, Calc AB and Calc BC to you all, but it was the integration test that I realized, I need to start over again. There's a lot to integration, especially now when you see this all mixed up together. All right, We got some people flipping through pages of notes even though all the formulas are on the board. All right. Do we have a square root in the denominator? No. So those two algebraic rules are out. Do we have a sum of squares in the denominator? No. So this rule is out. Do we have trig? Definitely not. So we're down to only 4 integration rules that's possible for this particular problem. Which of these 4 rules looks like it's the closest to our question? The one that involves natural log. So do we have a u prime over u? The denominator is a linear function. What is the derivative of x plus 1? Positive 1. So nothing involving a power of 2. So got to do division. Okay? The standout characteristic of this integrand is the division symbol. But yet, we can't use any of the integration rules that involve a division symbol. So we just have to just do the division and hopefully something nice comes out of it. And it is a textbook problem, so it probably will. Let's go ahead and do that long division. We have x plus 1 divided by, or going into, we have x squared minus 3x plus 2 divided by x plus 1. What makes x become x squared? What do you have to multiply by? X. So we're going to multiply by x and get x times x is x squared. X times 1 is a positive 1x. Do that subtraction. And we have negative 3 minus 1 is negative 4x. Plus 2. How do we get x to be negative 4x? Multiply by negative 4, obviously. So multiply by negative 4, and we get negative 4x minus 4. Do that subtraction, and we ultimately get a remainder of 6. So when we go through that long division process, we're not going to do that long division until we exhaust our, process, go through that, looking through all those integration rules that we have and realizing in its current form, this is not, you cannot take its integral. Then you go ahead and do this division. And we have a new integral, which is, we're going to have the integral of x minus 4. And then we have a remainder. So we have a remainder of 6. So plus 6 over what we divided by, which is x plus 1. You are going to have to do, okay, you are going to need to do this division anytime you have a rational function where the degree of the numerator is greater than or equal to the degree of the denominator. So you need to make a note of that because this is not an uncommon technique. So we've done a lot of integration, so I'm not going to separate this out now. What is the integral of x? 1/2 x squared, right? You take the power, you increase it by 1, and then you divide. What is the integral of negative 4 with respect to x? Negative 4x. And then the denominator is x plus 1. If that is my u prime is going to be, what's the derivative of x plus 1? Just 1. So we can let that 6 sit out front and just integrate 1 over x plus 1, which is the natural log of x plus 1, and then plus c. Bam! Don't forget your plus c. Do not get lost in a sea of desperation. Desperately seeking right answer. Ooh, that is a nasty long one. Okay, let's not do that yet. All right. This one shouldn't look too unfamiliar since it was near the end of chapter 5, which means it might be relatively difficult. But not for you all. Not for my BC students.
Oh my gosh, how do you? That's crazy.
How do I even teach this class? No, I'm just going to put a mark on that. Come on, Taru.
I think she gets a 4 point.
I just gave her one. Okay. Good thing Anna was looking over her notes. Okay, we have the indefinite integral of 2x over. I wish I wasn't so prone to that kind of stuff. But you all are always helping me out. X squared plus 8x plus 20 dx. Ooh. Thank you, Anna.
It is, yeah, it is.
Okay. What do you want to do?
I'll get there.
Okay, you all full-blown working this thing out. I want to do this together for the video.
I recognize that there's it's going to be I believe it's going to be a natural log because you have a second degree denominator and first degree numerator.
Perfect. So thank you for that. Another board point. Our denominator is a second degree and our numerator is a linear function. So it does look like we're going to have that u prime over u pattern. So what are you doing right now that you're writing on your paper because you love math so much? You're getting ahead of me.
So I figured out that u prime was...
First you let u be.
Okay, I let u be the denominator, which is x squared plus 8x plus 20.
Uh-huh.
And I let u prime is 2x plus 8.
And then dx.
Yeah.
Cool. But, right, not totally cool because what's going on now? There's no 8. So we have a 2x dx. In the numerator, we have a 2x dx. So that's all yippee skippy great. But we need a plus 8. Okay, well, how do you fix that?
I added 8 and then subtracted 8.
Yeah, you add 0 to the numerator in the form of an addition of 8 and a subtraction of 8. So there is our u prime. We have a 2x plus 8. Now there's some other stuff to deal with, but we have a 2x plus 8 over x squared plus 8x plus 20. So we have one of our integrals now that is going to be kind of happy and nice to work with is a 2x plus 8 over x squared plus 8x plus 20 dx. And then I'm going to let this negative 8 be like that coefficient. And normally it's going to be easier with integration if you let that coefficient float out in front of the integrand. So I'm going to have a minus 8 times the indefinite integral of 1 over x squared plus 8x plus 20. Now on the next line I'm going to write the answer to the first integral, but what do we need to do for the second integral? Question. Oh my God, did I make another mistake?
Well, because it was
Well,
You said,
I added 8 and subtracted 8, right? I need my u prime, I'm trying to complete the chain rule. So my du is 2x plus 8. So I added an 8 so I'd have a u prime over u. And then I subtracted by 8. And, oh, whew, okay, because I've made so many mistakes already. So that 2x plus 8 is in my numerator of my first fraction. I'm kind of pulling apart the subtraction now. So it's this fraction of 2x plus 8 over x squared plus 8x plus 20, and then minus 8 over that common denominator of x squared plus 8x plus 20. I'm just having the minus 8 move out front. Okay. So the first one's basically going to be done. It's natural log of something, natural log of the denominator. How am I going to integrate? What are we going to have to do to integrate this second term? No, I can't multiply and divide out a function. Like, that's more of like a... We have a lot of flexibility with constants and with constant coefficients of like multiplying by 1, which I didn't do that with this particular problem, but we can add and subtract like an 8. We can maybe multiply and divide the numerator and denominator like by a 4 or something like that. But doing that with other functions is unfortunately not going to work. Yeah, it's like the idea that, I mean, that's a correct answer, but is it like just coming out of like nowhere and you just, and I know you didn't guess. I mean, that's perfect, and I know how much work you do, so don't take that the wrong way. Like when we look at these integrals that are not easily worked, there should be some like thought into that process, right? It's not one of these first 4. It's not, of course, anything involving trig. And the only thing left that might be useful in our toolbox are these 3 integration rules that have division in them, right? Because it's not u prime over u. So since there's no radicals, you need to go towards that direction of making the denominator a sum of squares, right? So we're going to have to complete the square in the denominator to make that happen. Nice job. So it's keeping an eye on that mental or written list of integration rules and then using like what am I closest to help give you a suggestion and guide your work to finish the problem. So on the side here, bless you, I'm going to do x squared plus 8x, leave some room for completing the square, have a plus 20, and take half of b, square it. That's going to come out to be 4 squared, which is 16, and we're going to add 16 and subtract 16. So we have x squared plus 8x plus 16, and then plus 4, and this is a perfect square trinomial, which is the whole point of completing the square. Of course, that's going to be, your name's not going to be in the video. So we have the integral of u prime over u is the natural log of the absolute value of x squared plus 8x plus 20. And then we have a minus 8, that's absolute value, minus 8 times the indefinite integral of 1 over x squared plus 8x plus 16 factors to be x plus 4 squared. We want to write the 4 as a something squared. Okay, the constant probably should be first, but addition's commutative. So we have a plus 2 squared dx. And you guys know I don't like to do full-blown u sub with these integrations that involve formulas that involve inverse trig functions. So I'm just going to identify this. This is my u, this is my a, and just to double check, if u is x plus 4, then u prime is, of course, equal to 1. So our final answer from this really pretty difficult problem is the natural log of the absolute value of x squared plus 8x plus 20 minus 8 times, okay, now let's make sure this formula is right and we use it correctly, 1 over a, so 1 over 2 arc tangent of u over a plus c. And of course, 8 divided by 2 is 4. Bite! Excited. We got 10 minutes left. Let's do one more. We have, as our last example today, we've got an indefinite integral of 7 over 5 e to the x minus 2 dx. Take a few minutes and think about that one. You saved my video there. Thank you. There'll be a little red negative there for first part of the video. Unless you're doing integrals non-stop for like mass review for an exam, this is a tricky problem. So I'm going to give you some time to like fight through this before we work together. All right, here we go. I know that wasn't enough time, but we've only got 5 minutes left. So what does it look like this is going to be? What was the first attempt at working this out?
Natural log.
Natural log, yeah, of course. The trouble is you have an e to the x, and what's the derivative of e to the x? Another e to the x, and there's not another e to the x anywhere. And you don't have a sum or difference of squares, so it's not going to be involving an inverse trig function or of any kind of sort. It doesn't involve any trig, so all of these are out. All the trig functions obviously are out. We don't have a base of a, that's out. We don't have just e to the u, so that's out. It's really got to be something with natural log, at least giving us natural log as an answer. But we can't use the integral of u prime over u unless we get an e to the x, both in the numerator, some form of e to the x, or something. We need a base e in both the numerator and denominator for this to work. And in this format, it's not going to happen. You need a base of e in both the numerator and the denominator. And you don't want to get too complicated with the exponent because you don't want some chain rule to show up and make it even more complicated. So what you want to do with this is multiply the numerator and denominator by e to the negative x. And then, like if you multiply by e to the x, your denominator is going to have 2 bases of e, which means your numerator will have to have 2 bases of e. But if you do e to the negative x, this base of e is going to cancel. So we're going to have the indefinite integral of 7 times e to the negative x over e to the x times e to the negative x is e to the 0, which is 1. So we have 5 minus 2 times e to the negative x dx. Let me double check. Yeah. So now we're going to let u equal 5 minus 2 e to the negative x. And then du, the derivative of 5 is 0. The derivative of e to the negative x is e to the negative x times negative 1. So we have 2. That negative and the negative with the negative 2 are going to cancel. So we have 2e to the negative x dx. And look at what we have in the numerator now. An e to the negative x. Now, we are kind of past full-blown u sub all the time, and we've been doing a lot of completing the chain rule. So I want this numerator to become 2e to the negative x and not mess it up like I did with my first example in the video. So, and in this class. So I'm going to move the 7 out front. Are you stopping me for a correction? Okay. I'm going to get that question in a second. Oh, we're going to move the 7 out front. You were just going to tell me how awesome we are as a class. 2e to the negative x dx. So we're going to multiply. I need a 2 to be up here. So I'm going to multiply the numerator by 2 and balance that with the division of 2 over 5 minus 2e to the negative x. Yeah. That dx should be over here on the side. Cool. So our denominator is u. Slowing down to make sure I don't make any mistakes. My numerator is u prime. And so what's the integral of u prime over u? Natural log of the absolute value of u. So our final answer, double check and make sure I'm good here, is 7 over 2 times the natural log of the absolute value of 5 minus 2 e to the negative x plus c. Bam! We are done.
You did it.
No. No, it's bam.
Do we have to do it at the same time?
Go do your homework. No one makes it to the end of the videos. That was fun. Was that good?